In this lecture, we see how to find out the orthogonal trajectory of polar curve. So in this lecture, we discuss what is the method to find out the orthogonal trajectory of the polar curve. So first thing, suppose the given family of curve is f of r, theta and c, which is equal to 0. Means there is a relation between r, theta and one arbitrary constant c. Now, after if we have given this curve, so we will first differentiating above curves and eliminating the parameter c. We have the differential equation of f of r theta c equal to 0, which is given by f of r theta dr d theta, which is equal to 0. This is the differential equation of the given family of curves. Now, in the next step, for finding the orthogonal trajectory, we replace dr d theta by minus r square d theta dr. Then we get differential equation of f of r theta minus r square d theta dr, which is equal to 0, which is the differential equation of the orthogonal trajectory. And then solving this differential equation, we get the orthogonal trajectory of given family of curves. Now, there is a question that in the Cartesian curve, we have replaced dy dx by just reversing it minus dx dy. Uh, so why we are replacing, why we are not replacing dr d theta by only minus d theta by dr? Okay, so let us see over here in the polar form, the tan phi, so polar form, tan phi is given by r d theta dr. So this is what it is, the value of dy dx, we can say that in case of polar form. So r d theta dr. Now, if we know that m1 multiply by m2, which is equal to minus 1. So suppose m1 is equal to r d theta dr, so multiply by m2, which is equal to minus 1. So let us try to find out the value of m2. So what is the value of m2? m2, which is equal to minus 1 upon r dr d theta. Right. But now, if we see that if the given equation is like this, f of r, theta, and c, so suppose there is an equation which gives us r equal to, generally we are writing polar form in r equal to a cos theta, for example, a cos theta. So here we have the r which is written in terms of theta. So we can find out what is the value of dr d theta. We will find out dr d theta. So this dr d theta should be replaced by which value? So just look here. Here the tangent is, what is the tangent? Tangent is r. Let me erase this thing. We have the tangent is r d theta dr. Right. So if we find out the value of m2, it should be r d theta dr into m2 equal to minus 1. But if we find out the derivative of this equation, we get the derivative in terms of dr d theta. So what is the value of dr d theta? Or what is the equivalent value of dr d theta? So here so what is the value of m2? m2 is equal to nothing but minus 1 upon r dr d theta. So one side we have r d theta dr, and another side we have minus 1 upon r dr d theta. Now, the question is now, if you want to replace minus 1 upon r dr d theta by r d theta dr. So simply, if we do, what is the value of what, if we want to replace dr d theta, then what will happen? This minus r goes to that side and will become r square d theta dr, and that side we have dr d theta. Right, since we are getting the value of dr d theta, so that this dr d theta can be replaced by minus r square d theta dr. So in case of polar form, we have to take care of this thing. We are not just replacing dr d theta by minus d theta dr. We have to replace dr d theta by minus r square d theta dr. So I think this is clear to everyone. Thank you.